A data grid has distributed servers, each with a separate local rule base. Policy management requires the ability to ensure consistency across all rule bases. Each data grid server has an associated rule engine and rule base. The rule base is local to each server. Normally, the rule bases are identical with the same policies applied at every server within the data grid. When a user connects to a data grid server, the policies are implemented using the rule base at the connection server. A storage resource may have unique rules that only apply to that server. This is done to impose server-specific policies, such as interaction with an object store or tape drive. This can improve efficiency by making certain that the policies needed at a server are stored at the server. A distributed rule base minimizes delays caused by network latency. To make assertions about the entire distributed data collection, mechanisms are needed to track the consistency of the distributed rule base. Most data management applications install the same policies in each of the rule bases. The required mechanisms then consist of methods to distribute an official copy of the rule base to each server. The data grid administrator manages the distribution and update of policies within the data grid. Policies are stored in the etc iRODS core.re file at each server. This is a text file that can be edited by the data grid administrator. Policies can also be stored in the metadata catalog. The policies are versioned, are never deleted, and can be retrieved and distributed as core.re files to all servers within the data grid. The metadata catalog serves as the authoritative source for the policies applied within the data grid. A rule to distribute the rule bases to each server applies 3 steps. Retrieve rules from the metadata catalog into an in-memory structure. Copy rules from the in-memory structure into a file. Distribute the file to each server. Microservices are available to execute each of these steps. When a user issues a command or interacts with the data grid, a session is created. The data grid creates session variables that define properties of the requested action. The data grid also creates an in-memory rule base for each session. The in-memory rule base contains rules loaded from the local rule base core.re files. These rules are indexed by the policy enforcement point name to improve performance. Session-dependent rules are loaded from an ancillary rule file using the microservice MSI ADM add rule struct. A user can dynamically add rules or rule functions to the session rule base. Rules that are dynamically specified within an interactive rule execution. This includes rules that are executed from a local file and rules that have been loaded into the data grid. When a rule is submitted for delayed or remote execution, the rule engine has to package the rule and the input variables. This imposes restrictions of the specification of the delayed rule. Only the operations specified within the delay braces are packaged. Any policy functions that are invoked have to be stored in the rule base core.re file. No session variables are packaged. Their values must be saved in workflow variables. All writes need be made to either the server log or to a file stored in the data grid. Some structures such as queries do not have an associated packing instruction. This is handled by creating a separate function that issues the delay command. All input needed for the delay execution is listed as arguments of the calling function. Take 7 minutes and complete exercise 119. Outline the steps needed to manage policies that your collaboration wants to enforce across all sites that are providing storage resources for the shared collection. Please load a paragraph describing your result into the lifetime library in the subcollection class INLS 624 by the end of today's class.